Hey guys, welcome back to my YouTube channel, Mazatrol Tips and Tricks. If this is your first time here, my name is Phil, and I teach people how to run a Mazak CNC lathe while programming it with Mazatrol. If you want to see more of this type of content, be sure to click that subscribe button and hit the bell so you won't miss anything. In this video, I'm going to show you guys how to use the manual process, or MNP, to cut off the part and perform a bar pull operation. I will also loop the program using the end process so the machine will keep going after it finishes the part. Be sure to watch this video all the way to the end because I have a few tricks to show you about saving the bar pull program in another part of the machine where it will not interfere with the program. So it's like a hidden way to save a process. All right, let's get started. All right, let's get started programming this part. What we're going to make are some 1-inch 700 discs, 300 thousandths long. So this is just a dummy program to cut off some parts to show you the bar pull operation and looping the program with the end process. So what we need to do is create a new program. So push the left button, go to Program, Program File, and we're going to select a work number that's not listed here. We're going to select work number 26. So go back to Program, work number 26, Input. It's a new program, push the Program button. Mazatrol or EIA, Mazatrol. Workpiece material is aluminum. Maximum outside diameter of workpiece is 1.75. That's the size of my bar stock. Inside is 0. Workpiece length, I'm just going to say 1 inch. This doesn't need to be the total length of the bar. This just needs to be the length of one individual piece. Max spindle RPM limit is 2,000 RPM for the whole program. Finish allowance on X. Normally I would say 10 thousandths on X, 5 thousandths on Z. Stock removal of work face. I'm going to cut off 20 thousandths off of the face of each part. So 20 thousandths, stock removal on Z. First thing we're going to do is turn on the coolant. So push the 3 arrows, M code, coolant on, down arrow. Now we're going to face the part off, edge, auto. And in this case, I'm not going to have a roughing tool. I'm just going to use a finish tool to finish the face. So finish tool number 4, offset 1. Starting point on X is my start size, 1.75. Starting point on Z is 20 thousandths. Final point on X and final point on Z are 0. And I'm going to leave the surface roughness at 0 so it finishes at the roughing feed rate. Next thing we're going to do is turn the OD bar out, 1.75, auto, and again I'm just going to use one finish tool to cut the part. We're going to do a linear. I'm going to do a 30 thousandths chamfer at the front, 1.7 inches in diameter, and I'm going to turn it back 300 thousandths plus 125 for my cutoff, plus another 25 thousandths. So the insert isn't into the radius, so the cutoff insert doesn't touch the finish radius and deflect. I want to have a nice clean diameter. So the final point on Z is going to be 0.450. And again, I'm leaving surface roughness at 0. And I want a linear with a 20 thousandths chamfer, 1.75, and 0.450 plus 20 thousandths plus 2 thousandths, so 0.472. So that way the bar is pre-chamfered for the bar puller. Down arrow, shape end. So now what we need to do is program the cutoff operation. And on this machine, I have a cutoff tool and bar pull in one tool to save me room in the tool chain. So I have a dual use tool. And I'll show you and here's what the tool looks like. So you can see it has a cutoff tool and also an adjustable heavy duty bar pull. All right, let's go back to programming. So we're gonna go manual program, exchange point of tool, yes, with the number 1. Gear number, we always have to give it a gear number whenever we're using the manual process. So gear number 1 for this machine because it only has 1 speed. And tool number is going to be tool number 5. So now the first thing I want to do is rapid G0, final point on X 1.8 inches, final point on Z is minus 0.425. And what that's going to do is give me a part 300 thousandths long, and then because the cutoff tool is 125 thousandths wide. So surface speed for roughing, I'm going to give it an RPM of 1200 RPM. I don't want to run this thing wide open because I would like the parts to land in my bucket and not get flung all over the machine. And then offset number 1. And now the next thing we're going to do is do a G1. We're going to feed into the part to 300 thousandths with a feed rate of 0.006. And then I'm going to slow the feed rate down. So G1, these are all modal, so I don't need to put a second G1 in here. It's not necessary. But final point on X is 0. And then slow the feed rate down to 0.002 input. And then the next thing I want to do is shut off the coolant after I get done with the cutoff operation. On this older controller, if I put an M code here, it's going to execute the line here, and then it's going to execute the M code. So I can put a coolant off button right here, and it's going to cut it all the way down to 0 and then shut off the coolant. On the newer machines, it'll execute the M code at the same time as the line, and you don't want to do that. So on this example, I'm going to program it like the newer machines. So I'm going to give it an M code on its own separate line, coolant off, down arrow. So now what I need to do is go into rapid, and I'm going to increment the tool, push increment 0.150, and it's yellow, and I'm going to increment I'm cutting it off, and I'm going to move over to the right 150 thousandths to clear based on the shape of my cutoff tool holder. I can't run all the way down the side of it because it'll hit the workpiece in the chuck. So I need to move it over 150 thousandths from wherever it left off. And if you use an increment function, that makes it a lot easier instead of minusing 150 thou off of the Z position. And then the next thing I want to do is stop the spindle on its own line. So push spindle stop, down arrow, and we're still in G0. So the next thing I want to do is come down, rapid down on the X dimension to the center line of my part off, or to the center line of my bar pulling tool. Because it's a combination tool, I have to put in a minus value. Because this is a combination tool, I have to run the tool past X0 in order for the bar puller to grab the part. So I want to show you guys here. I can measure the tool. So right about there, so I can go 10.7. And that's right about the center of my part. Yeah. So I stopped the spindle. So now what I want to, all right, so now the next thing I want to do is wrap it down to minus 7.5. And then what I want to do is do a G1 move, because I don't want to rapid the bar puller over the stock. I want to feed it in a controlled manner. So minus 10.5. And then we're going to push feed rate per minute and go 100 inches per minute. And then what we're going to do is open the chuck. And we don't have the M code on the screen here, but M6 opens the chuck. So 6 input. So now what we need to do is move our part out of the chuck. And I'm going to push the increment button. And I'm going to increment it 0.445 in the positive direction. And that will give me 20 thousandths stock for the next workpiece. So now what we need to do is go M7 and close the chuck. And now we need to feed off of it. Turn off the increment, minus 7.5. So it feeds up. And we're going to rapid to a 5-inch and 5-inch. And then we're going to turn the optional stop on. So that way, after it does the bar pull operation, it'll stop the part if we have the M1 lit up, and then it will continue on. So shape end. So that's the process to cut off and bar pull our stock. So now what we need to do is end the program. So push end, parts count. If we put a 1 in here, it will count the parts for us. Return position, leave this at, we usually leave it at 0. It'll go back to its tool position. Next workpiece number, we're going to leave this at 0. This is used if we want to have the machine change the workpiece number. And then if you want to hit cycle start automatically, you would put a 1 in here. But we're going to leave all 3 of these at 0. Repeat times same program. So I want to run 3 pieces total. So put in 3 input, and then the Z-axis shift amount is going to be 0 because we're doing a bar pulling operation. I'm going to pull the stock to the 20 thousandths in front of 0 in order to run the next workpiece. If we put a shift amount in here, it will crash the machine when it runs the second part. So do not put a work shift in here when you're bar pulling. Very important. All right, so now let's look at the program. Check. shape. So we have the face and we have the OD turn, store, and check continue. It's going to face the part off. It's going to turn the diameter. It's going to cut it, wrap it over, wrap it down. It's going to feed downward, feed over, and then feed up. So in order to see that, we need to zoom it out much further. So scale 4 input. Yeah, 3. All right, let's run the part again. And then this feed line, the solid line, that's our bar pull. Feed down, pull over, and feed up. And we're done programming the part, so now we need to set the work shift. All right, let's set the work shift for our part. Turn on the spindle. Stop. Program file. Z offset teach. 0.02 input. We're 20 thousandths in front of our part. And auto work number 26. And we're 20 thousandths in front of our part. We are called up. So now we can run the program. And we are going to turn on the optional stop to stop it between each part. And let's go. All right, turn off the optional stop and run part number 2. And here comes part number 3. And we're done. All right, now that we're done running our program, what I want to do is I want to save all of the work that we did programming the bar pull operation. So we can do that by saving it in the middle of a program like our job boring program, for example. All right, now that we've run this part, what I want to do is I want to save this long bar pulling operation. I want to save it in another part of the machine. And I want to save it in one of my job boring programs. So this is workpiece number 26, process 4. So let's go to program work number 2. And I've already got it saved in here. And I've already got a bar pulling program saved in here the way this machine will run with the M codes at the end. But what I want to do is I want to copy the program we just made and save it in here. So what we're going to do is we're going to go process copy, workpiece number 26, input, process number 4, input. Now it just copied that long bar pull, bar cutoff and pull operation that we just created. And then what we're going to do is we're going to insert, input, shape end, end. So we're going to insert an end process above it, and what that does is it does not interfere with my normal bar turning operation for the cutting the jaws. So this is a program I keep in the machine all the time, and once it sees the end process, it stops. However, there's a process 4, and then it'll have another end, and process number 6 is the one that I have. So what we can do, so this is workpiece number 2, process 4. So when we're going through and programming a part, work number 26 for example, and we just got done turning the outside of the part. So what we want to do is we want to copy a standard bar pulling program into the machine without having to rewrite it every time. So I push the right button, go process copy, workpiece number 2, input, process number 4, and it copied it in. And what I'll usually do, and then you can change the X, Z values, and then the increment distance. So the starting point on X, starting point on Z, and the Z distance pull-out amount are usually the 3 fields that I would change. It's always going to be tool 5 because it's my combination bar pull tool. So these 3 fields is the only thing that I change when I'm running the bar pull operation. So that's a way to save the program and then edit it without having to recreate it every single time. And there's our 3 finished work pieces. If you like what you see, go ahead and push that subscribe button and click the bell so you won't miss any future videos we have coming out. Thanks for watching.